What's up, guys? Joey here. Welcome to my Radeon driver stability guide for 2022. And I'm doing this guide mainly as a AMD full team red user for the past few years now, and switching from Intel, NVIDIA to all AMD, which is what I'm currently running, a 5600X and RX 6700 XT. I've also been on a Ryzen 5 3600 and RX 5700, so I've done at least one full generational upgrade on AMD, and I've run into a few of the issues people have mentioned, and I've actually been able to reproduce them. Like, I could literally cause my system and my Radeon driver to start crashing right now if I reverse some of the steps that I do. So I figured, why don't I just share these tips? Because if it's working for me and it's worked across two different CPU and GPU builds in recent generations, maybe it could help a bunch of other users. And I'll also share with you my thoughts on why these are helpful, why the tips are helpful. So first off, you want to go into your BIOS and make sure you've set PCIe Gen 3 if you're on an older platform. So if you're on B450 or older motherboard, set it to Gen 3 only instead of automatic. And I believe the reason this may help resolve some black screening issues is if software or BIOS or a conflict between the drivers, something is coded wrong and makes a Gen 4 call. And I'm not saying that this is like 100%. I could just be completely off, but it's a possibility that there's a hardware incompatibility where the GPU or software is trying to switch to Gen 4, and because it's left on automatic setting, the call goes through to the motherboard, and the motherboard doesn't support it. So obviously that would result in the GPU dropping out or producing a black screen. And I'm not saying that that's exactly what happened. It's a very layman's way of explaining it. But on my first RX 5700, I was getting black screens, and when I set it to Gen 3, forced Gen 3 mode only, not having it on automatic, the black screens were far less. But that wasn't the only step I've done. It's a combination of different things. So that's just one thing I would just make sure, because it doesn't hurt anything. Okay, and number two is whenever you install your fresh drivers, especially in a brand new card, but also when you're updating between drivers, make sure you disable ultra low power saving mode. And ULPS seems to be involved in causing idle crashes or idle black screens where normally your computer would go into standby mode, and then, or you've walked away from the computer, you come back and your system's still running, everything seems like it's turned on. You might even have a video playing in the background, but your screen's just black and you can't get the display to produce an image anymore. And turning the monitor on and off doesn't work. It's not a desync, it just does not come back, and you have to hard reset the computer to get your picture back. And I believe it has something to do with ultra low power saving mode in Windows and AMD cards. And so I've just made it a practice is after every driver update, I go into MSI Afterburner. This is a good app for running on-screen displays. And in here, there's an option to go disable ULPS. But you can also do it via the registry. You can create a little bat file, which will automatically do it when you run the file, and you just run that bat file between driver updates. That's a way you can do it without using MSI Afterburner. So just look it up, how to disable ULPS on Windows 10 or 11, depending on which one you're running. And in regards to MSI Afterburner, it is fine to run. There are a few rumors going around saying it is incompatible with AMD, it doesn't work because of the Radeon software driver control, blah, blah, blah. As long as you do all your tuning through the Radeon software, you won't have any problems with MSI Afterburner. But there is a conflict, a hard conflict that appears when your GPU supports 0 RPM mode. And for some reason, this is from my own testing, if I leave 0 RPM mode enabled, I've got it completely disabled via the registry now. But if I leave it enabled, which is default, right? So especially after a driver update, and I'm also running MSI Afterburner in the background, and so my driver's up to date, and I've just rebooted the system, I will notice the Radeon driver will become unstable, and my fan behavior will be weird. Like, it'll either be stuck on 0, or it'll go all the way to 100%. Like, it'll just do weird behavior. And I figured out it only happened when I had 0 RPM enabled. And when I disable 0 RPM and I just leave MSI Afterburner alone, like I don't touch it for any type of tuning, I just have it for the OSD, as long as this is set on auto, all the rest it'll just show me what I've set in Radeon software, but it won't actually try to interfere with it. So that's how I have it set up, and I just use it for the OSD, which is via monitoring. And you can see here I've got all sorts of OSD stuff running. Okay, so that's what I use it for rather than for any tuning. I do not recommend tuning because it will conflict, like it'll mess with the driver tuning as well. So anyway, that aside, I make sure ULPS is disabled through the checkbox. It'll ask you to reboot, and yeah, that's one more step. And then I'm going to go into GPU tuning, which is more to do with, and the reason I believe this helps with stability a lot is because if I install a fresh driver and I do not tinker with it, if I do not set my own custom profile, which I know is stable, a custom undervolt or underclock, I will literally get driver crashing. And the icon will disappear. I might get I used to get like 5 icons at the bottom. In Windows 11, it doesn't happen so much, but more the icon will just hang, and then it might disappear and reappear. And that's the driver basically crashing. Whether it be hardware or software errors, I don't know. But since 22.3.1, which released the other week, since that driver, I noticed it was much more sensitive and it was happening more often. And I do believe it's to do with the way Radeon fan profiles and drivers, how we've got this GPU tuning section that shows the curves and stuff. I believe it's something to do with how the drivers are communicating with the aftermarket card BIOSes, because every aftermarket card has a different voltage curve and a voltage range, as well as the fans have their own voltage curve and voltage range. And I noticed on my RX 5700 and on my 6700 XT that the fan profiles or fan curves that I would set in the drivers were never accurate. Like I could set any kind of profile in here, and the way the fan would actually behave in comparison to the profile was always off by like 20%. So I could set like 70% here for 60 degrees, and at 60 degrees, I would be getting 90% fan speed. And I noticed that between two different models from different manufacturers of card. And I also noticed AMD messing with the minimum voltage. Basically the voltage curve was changing between certain driver updates. And it got to the point where now in 22.3.2, they have completely removed the minimum and middle voltage adjustment. They've only got a max voltage adjustment here. So we used to be able to change 3 different voltages. Now we can only change 1. And I believe that's also in part, that's AMD trying to improve compatibility. That's the best way I can explain it. And it could also be them trying to stop users from accidentally causing their card to become unstable. But in saying that, in their attempts to do that, it's actually introduced more instability to my system at default. So yeah, when I upgraded to the 22.3 drivers, I was getting crashing, and then I had to reload my profile, and then it was so unstable that on a fresh boot up, before I could load my profile, like after the drivers had installed, my driver kept crashing. I couldn't even load my profile. So I did a workaround method. But first off, I'll show you what it means to do a underclock/undervolt. And basically what it means is you go into the performance tab, go to, here it'll be on default, change it to custom, enable GPU tuning, and this is more applicable to recent models of GPU, so 5000 and 6000 series especially, but you can still use it on older models. But the main idea is by default, your minimum frequency will be like this, and that affects the voltage curve and idle/low load frequency and voltage. And that can be where some of the instability and the driver crashing is being caused by. So by default, it's 500. I bump mine all the way up to 1500, which is around 1000 megahertz higher, or lower, I should say, than my max frequency. And then the max frequency is around, for my card, it's around 2689 megahertz or 2750 megahertz. I just round it down to 2600 megahertz. And then the stock voltage, this part is kind of, you have to know what you're doing. If you have not tested, if you haven't done any tuning and you don't know a stable undervolt, do not attempt to undervolt. Just do the underclock first, and then slowly undervolt, maybe in increments of 10 MV at a time. So instead of going, so if by stock you had 1200 MV, you'd try 1190 MV. So you just do it like this. Like for example, if this was your default setting at max 1160, you try 1150. And have your 100 megahertz lower than your default speed. So whatever your default speed is, if your default clock speed is 2800, set it to 2700. So you get the general idea. About 100 megahertz lower, and then drop 10 MV on the voltage, and then save it as a profile. And when you've done that, see if stability is improved. If it hasn't, try going a bit further. Drop another 10 MV and drop another 50 megahertz on the max frequency. And yeah, basically doing that in steps will be a safer method of doing it. If you already know what you're doing, then yeah, you don't even need this guide, but that's the general way to do it. And with my previous card, about 100 megahertz off the max frequency and 40 to 50 MV lower than the default maximum voltage is what I would do. So if your default's 1100, try dropping it down to 1050. Okay, so just to give you that rough idea, and that may help you get stability as well. If your junction temperatures are hitting really high by default because of the fan issue that I spoke about, you may want to try a custom fan curve. But given there's an issue with how some aftermarket fans behave via driver tuning, you may want to either try downloading your aftermarket card software. So, there's Sapphire software, Gigabyte, they all have their own fan control software that you could attempt to use. But I found a better method that I actually use for myself, which bypasses the drivers completely, almost completely. And that is because I was having annoying things where if you do a custom profile, so for example, Undervolt is one of my custom profiles. You can see how I've set it up here. And then there's fan tuning, blah, blah, blah. If you do it this way and then you get a system crash or you get a power outage, which are very common here in Philippines, what'll happen is it'll reset this and you might not realize you haven't loaded it again. And you'll be at the desktop after a power outage and your undervolt or your underclock is actually not enabled, and then you'll go to start playing a game and it'll crash, or your driver will start crashing. And remembering to reload it can be very stressful because it can just happen randomly that it hasn't loaded because of that power outage or system crash like something else could cause your system to crash, nothing to do with the GPU, and that'll reset your driver profiles. So the workaround method is to use More Power Tool, which is basically a driver registry editor that the driver reads from it, but it's based off the BIOS of your GPU. So your GPU BIOS gets read by the drivers and Windows and goes into the registry, and then your GPU settings that the driver reads are in the registry. So it's not reading off your BIOS every boot, or it kind of is. If you switch the profile, it'll change it, but it's basically taking settings from this registry section, and you can modify that outside of the Radeon software. And the reason this is a really good method is if you do get power outages in your area, so especially third world countries, between crashes, the More Power Tool profile will still be loaded. You don't have to reload anything in Radeon software. It'll just run off this More Power Tool profile. So first I'll show you how to use it. I'll give these two links in the comments below. The first one you need is GPU-Z, which allows you to extract the BIOS from your card. And you're not going to modify your BIOS. This is not BIOS modding. It is just getting the BIOS to read the data. So, for example, GPU-Z, after you download it and you run the exe, it'll open up like this. Go to the Graphics tab, and this will let you extract your BIOS. This little button here next to BIOS version. So you want to do that. Save to file. So save that somewhere. Call it custom BIOS. Call it BIOS, whatever you want to call it. I've got custom BIOS here because I was going to BIOS mod, but I ended up not doing it. Just call it whatever you want and save it somewhere. Then close GPU-Z and run the More Power Tool, which will also be linked down in the comments below. And in More Power Tool, especially after a driver update, or if you've never done anything before, when you select your GPU, there's a drop-down box, so you can see my RX 6700 XT. This will actually all come up as blank. All this stuff will be blank. And what you got to do to get it to work first is you load your BIOS settings in. So this is not modifying your card. This is just loading the settings for More Power Tool to access your registry, to access the correct settings to put into your registry. So after you've opened that, you'll see a bunch of settings. So these are my default maximum clocks. It's got my default voltage, which is 1200 MV. It's got the default. So my default frequency, was 2854 by default. And I'm running all the way down at 2600. So I'm actually running like literally 200 megahertz lower. But in real world use case, the performance difference is actually very small. I could probably do 2700 if I wanted, but I like the temperatures at the frequency that I run. But long story short, I'll show you which settings to change that correspond to a custom undervolt. So after you've loaded that BIOS in, first go to the Power tab, and this is your voltage. If you're undervolting, if you're not sure, then I recommend just doing it through the driver first, finding a stable setting that you've tested stable, so you've tried it in a few games and the driver's not crashing anymore. That is when I would lock in your undervolt and put it into More Power Tool. But if you haven't done it, don't worry about that for now, and just go straight into frequency, which is underclocking. And whatever your max frequency is, drop 100 to 200 megahertz on it and round it down to the nearest 100. So for me, if it was another person with the same model card and they were just trying because they're getting some driver crashing, I would say try 2800 or 2700 megahertz, like that. Okay, and then increase the minimum frequency to 1500. That helps with games like League of Legends that don't actually load the card that much. It helps with stability. So that's what I've personally tested. Having it about 1,000 megahertz higher around this range is what the card tries to run anyway. But when you're going between screens and menus at the end of games, it stops that weird like random crashing or black screens that you might get in League of Legends. So that's what I run, what I would personally suggest, but you can try different values. But that's around, a little bit more than 1,000 lower. But you can just see 1,500 megahertz minimum and 2,700 max. And then for the fan thing, where I was saying how the fans were behaving weird, I find it much more stable to go through more power tool, and see how the default target temperature is 80 degrees. This is why my fans, if I didn't make a fan profile, would actually let my GPU heat up all the way to 90C on the hotspot in an intensive game. It's because the target was way too high and the fans were taking forever to actually spin up. So what I actually changed it to is about 67, and that way I get a hotspot of about 70 degrees with my underclock, and it is rock stable. Like, you've seen my gameplay videos if you've gone through my channel, all my recent uploads in the past few months, I've got like 1 to 2 hour long sessions with recording, which puts more load on the system, and it's just rock stable. So you can lower that target down whatever you want, and if you're having issues with MSI Afterburner and you don't want to keep resetting it every driver not every driver update, but between crashes or between any issues. I don't normally get crashes, just to stress. This is just something I've noticed, especially after power outages, which I can't control, is disable 0 RPM, which this completely disables it. You won't even see the switch in the driver anymore. And then after you've done all those settings, click Save, and save a profile. And it's saved as .mpt, which is basically a more power table or more power tool file. So you can see I've got one saved there. And then after you've saved it, click Write SPPT, and that writes it to the registry. And what that means is, even when you first boot up and you haven't even loaded any profiles yet, it's like this, you'll have all these settings already running by default. You'll have your underclock, and you're not even using the drivers. And the reason this is really helpful is if your driver crashes specifically, right, this will load before you don't have to worry about getting into the tuning section, because it might be crashing too much that you can't even modify anything. So this is like a workaround method to get an underclock that will stabilize your drivers, and then you can navigate, you can click stuff, you can go to the gaming tab. I can't actually do this without doing the more power tool method for the 22.3 drivers. So I hope that'll help a bunch of you out. And the only thing you have to be aware of is between driver updates, you do have to load this again, but you don't have to do all the steps. So between driver updates, all you have to do is, instead of loading the ROM again, the BIOS file you had, you just load the profile you saved, so MPT. So if I load that, you'll actually see a few different values in there. I've got my undervolt there, I've got 2600 on the max frequency, and then I've got my fan here at 68, 0 RPMs disabled. And then to enable, to load this power table, I just click Write SPPT and reboot, and that will be loaded until the next driver update. Even if my system crashes or if there's a power outage or anything like that, this will be loaded. So, and Write SPPT, also make sure you select your GPU, because if you do it without selecting, it will also just not do anything. So yeah, and Write SPPT, and it takes like a second. Like, I'll do it now. It doesn't really hurt anything. That's what it looks like. Successfully added. And then this is what it looks like in the driver. If you actually try to check that your settings did something, you can see how I'm all on default. And if I go to custom tuning and check what my max voltage is, it's now the undervolt, which is 1163, 1162 MV. The max frequency is defaulted to 2600, and the minimum frequency is defaulted to 1500. And I don't have to worry about messing with the fans, because the fan behavior is much more in line with what I want it to be. It spins up to around 50 to 70% at around 70 degrees on the junction. And you can see that in my most recent few uploads playing Elden Ring. Since the RSR driver update, you can see those temperatures and fan speeds are a fair bit lower than the default profiles I was running. And that's because the fans behave properly when I do it via more power tool with the maximum target temperature. They just don't behave properly at all when I was using custom curves. It just did not work the way I wanted it to. So yeah, that's it. If you are still getting driver crashing, there are obviously more troubleshooting steps you can go through, but I don't want to make this video like an hour long. So all I'm going to say is if you try this method and you do a slight underclock, you drop your clock speed by 100. If that doesn't work, try dropping it by 200. So if your default frequency is 2400 megahertz, try 23, then try 22, and just write the SPPT and reboot. And if that fails and you're still getting driver crashes, then I would start looking elsewhere in the system and not necessarily blame the graphics card. Because even though the graphics card might be a new card and your system was completely stable on an older, weaker card, that doesn't mean that the new card is 100% at fault. Because the way the driver and the card loads the system, including the CPU, will be different than an older model, weaker card. So if you're having higher system load, something else could have become unstable from upgrading your graphics card, not necessarily the graphics card causing the issue, even though it seems that way. So the main things I would look at is your overall system temperatures. So make sure you've got good case airflow, the wiring of your GPU, which I'll link in the comments below as well, a little diagram that shows you how your GPU should be wired up, which is 2 separate runs of PCIe cable, not a splitter. And one more thing that you have to be aware of is, I'm getting a mind blank. Your system RAM, sorry. So if you've ever enabled XMP and it was stable on a weaker GPU, that does not mean that it was always stable. There could have been a slight instability that upgrading your GPU caused a bit more heat in your system or placed a bit more load on your CPU because you're pushing higher frame rates with the new GPU, if that makes sense. And what that's done is that has caused an instability that was always there to appear. So that it was always unstable. It just, your system was never able to produce high enough levels of frame rate and bandwidth consumption. So bandwidth is data between the GPU, CPU, and RAM, right? And your system was just never pushing your bandwidth limits or your RAM hard enough or your CPU hard enough to make that instability crash your system or crash your applications or crash your driver. And then once you added your new GPU, you've got more heat, you've got more bandwidth being used. And not necessarily at the desktop, though. I think underclocking and undervolting will resolve most of the desktop crashing issues for cards that are not faulty, but mainly under load and light load, that it could just be a RAM stability issue that seems like your GPU driver, but it's not your GPU driver. Because when my RAM was unstable, I would get driver crashes and I would have games randomly crash, and RAM instability can behave exactly the same as GPU instability, except you won't get artifacting. You'll just get crashes and driver crashing and software crashing. So yeah, if you do need help with RAM stability, I was planning on doing an updated guide because I've changed my method in the past couple months to a better method, a more thorough method. But I'll only bother uploading that if enough people really asked, hey, what are you doing now? Like, can I have your RAM stability test? And if I had a few people messages, then it would be worthwhile to upload it. But for now, I'll just stick to the GPU stuff. So yeah, and as well, at the end of the video, if you were not aware, today is, what is it today, March 27. I think it was yesterday or today or just in the past few days, AMD also released this driver that is for Ghostwire Tokyo. So 22.3.2 is out. It says release March 22, so I don't know. Sometimes the dates are off for me. Like I noticed I was checking for updates like a few days ago and it didn't say it. So yeah, if you're not aware of that, download it, especially if you're going to play Ghostwire, and I'm going to be uploading some Ghostwire gameplay soon. I appreciate all of you guys for checking out my videos, and yeah, thanks for watching, and have a good one. Take care. Bye.